Hi everybody, this is my fourth episode of my YouTube channel. Today is 19 January 2026. In the episode 3, I talked about the transformer operation and maintenance, a little bit of design, and I said that I will discuss the oil analysis in another video. Today I will discuss the oil analysis. But before that, the last episode was a bit of rambling. So I just want to do some summary what I discussed in last episode. Basically, I discussed about the when you buy a transformer, at least what I used to do, I used to pay a lot of attention on the mechanical design in addition to electrical design. Normally, vendor will give you the transformer data sheets and other thing. But for critical transformer, I used to probe that what will be the cooling design, how many radiators, etc., etc. And when I used to get the drawing, I look very carefully about the oil quantity and the radiator design and ask questions. And definitely for critical transformer, I will insist on heat run test and witness the heat run test. That is very important. Once you ask for the heat run test, vendor take a lot of care to design the transformers. So for critical transformer, I will always insist on heat run test. At least one heat run test for a series on particular design, I will always insist. And then after the installation, I used to do a lot of tests, especially the standard test as per the site test. And one of the critical tests is TTR, like transformer trans ratio. That is obviously many people do. But another thing I will suggest to do the winding resistance measurement test, the DC winding resistance. That helps for a very old transformer that helps actually to decide replace or repair for a very old transformer when other data comes about actually. Okay, so that is the design and of course the one need to check all the protection system before it is commissioned. So and during the maintenance, we said maintenance transformer is not very difficult. You basically check the temperature rise. The temperature rise should not be more than 55 degree to 60 degrees Celsius, even if the transformer is fully loaded. If it is more than that, then there is a problem in the transformers. We will discuss this in the oil analysis a little bit. And beside that, if the transformer has got a silica gel breather, you change the silica gel. If the transformer has got a nitrogen cushion, you look at the nitrogen pressure and all this thing, and you take oil sample to do oil analysis. That is the most important. So oil analysis, and then as I say, for 5-year maintenance, you check all the connections for any corona discharge and the bushings. And OLTC, as I said, I off late my last when the vacuum OLTC came into the market, I always specify vacuum OLTC. So if you have a vacuum type OLTC, it is basically maintenance free. You don't need any maintenance. Okay, now the oil analysis. So it is very there are a lot of literature available. IEEE C57104 give a very clear indication about the oil quality, etc. But I found there is not much literature available or standard available when exactly to change the transformer. Am I going to change the transformer now or trying to repair or what? That clear indication and risk analysis is not there. And that is because any one data cannot give the health of the transformer. One has to see all the data, and there is not many analysis or not many paper to look into all the data and give a clear instruction. See, electrical engineering, like physics is well in balance. Everything is in balance. So if something goes wrong, the other thing also will show it. So when we do the data analysis, we have to do a total data analysis and make a judgment what to do with that actually. So the transformer repair, of course, is very costly. Even inspection is very costly and time consuming. If you untank the transformer, it is very, very difficult and costly. So it has to be data driven from the oil analysis. So as we discussed last time, the oil analysis is two types. So oil analysis is one is the basic oil analysis, which is the acid number, dielectric strength, interfacial tension, moistures, breakdown voltage, oxygen content, dielectric absorption ratio. But the most important oil analysis is a dissolved gas analysis, which gives us a much better data to to ascertain the transformer health, like how long the transformer life remains, whether we should replace the transformer, and what are the improvement we can do. Let's first discuss the standard oil analysis. Standard oil analysis includes uh, mm, moisture content, dielectric strength, uh, breakdown voltage, which is the dielectric absorption ratio, and interfacial tension, and acid number. Okay, and these are actually also interrelated a little bit. And the data is there in the IEEE, but I just say that again. So normally acid number is the potassium hydroxide milligram per gram. So the acceptable value is less than 0.2 milligram per gram, but more than 0.4 mg per g is bad. Okay, so what happened actually, if the acidity result in oxidation, and that increase the corrosion in connection, very simple. Okay, so you cannot have very high acid number. Interfacial tension is the opposite. Basically, there's a correlation between acid number and interfacial tension. If the acid number goes high, normally the IFT goes down, and vice versa actually. The interfacial tension is the oil-water interface. It is a sensitive indicator of the oil contaminants. So when you see the moisture content is high or something like this, you also look at the interfacial tension. You look at the acid number. So all of these together need to be seen. So interfacial tension means if it is normal is about 40, more than 40 Newton per meter, and the less than 25 is bad. So the unit is millinewton per meter or something like this. It's a surface tension, yeah. So less than 25 is bad, more than 40 is good. So again, correlation between acid number and IFT. If acid number is high, IFT is low. So moisture we already discussed. The less than 30 ppm is bad, and the less than 30 ppm is good. More than 40 ppm is bad. And as I say, we need to take this with a pinch of salt, because a transformer that has got a 20,000 liter of oil, 40 ppm is pretty bad. A transformer has got 5,000 liter of oil, 40 ppm may be okay, acceptable. So something like this. Okay. So but moisture content, anything above 30 ppm is not good. Above 40 ppm is definitely bad. The dielectric absorption ratio, it is basically energy loss in AC field. So when the transformer is in the AC field, so that's the dielectric absorption ratio. So actually it indicates the moisture in the overall oil and the paper. So dielectric absorption is like a typical is basically it's a energy loss. So less than 0.5% is good. Anything more than 0.5, it has to relate to temperature also at 90 degrees Celsius. So less than 0.5% at 90 degrees is good. Anything more than 0.5% is kind of a not good. More than 1% is definitely bad. Okay, and then of course the breakdown voltage. Breakdown voltage must be more than 30 kV. Another thing also we check is the oxygen content. There is an oxygen inhibitor is there in the oil nowadays, but oxygen content is also very important. If the oxygen content, nowadays the transformers are hermetically sealed, so normally there should not be much oxygen. But even if it oxygen content hermetically sealed, there is always some oxygen inside, because somehow it goes inside, or maybe it is from day one. If the oxygen content is more than 2000 ppm, that is also not good. So one have to be careful about oxygen content more than 2000 ppm. So a lot of people think, okay, dielectric strength is I can get the oil quality by dielectric strength. That is not true. The dielectric strength is not a very good indicator. We need to remember that actually. if you have moisture in combination of oxygen and heat is always there inside the transformer, that will destroy the cellulose long before a dielectric strength indicate anything significant. So dielectric strength, you are very happy. My dielectric strength is more than 30 kV, but that doesn't say much. Okay, if dielectric strength will become bad, but by that time transformer is very bad actually. Okay, so this is the standard oil analysis. If the standard oil analysis gives you a lot of data, if the acid number is high, you might have corrosion, high corrosion. If the interfacial tension is low, you have more moistures. If the moisture is high and if your oxygen content is high, corrosion is taking place, the transformer life is less. Breakdown voltage is not very good indicator, so don't worry too much about that. Dielectric absorption ratio is good because it is the energy loss into the AC field. It talks about the strength of the oil. Okay, so if any of the data is bad, one can do oil filtering. It will improve the oil quality. If the dielectric absorption ratio is very bad, that means there's a lot of sludge formation happening actually. Okay, so the good thing is that one can do filtering of oil, or you can replace the complete oil. As I discussed in the last episode, that if the dissolved gas is there, you can't do much help, because dissolved gas is coming from the other problems like heat, paper cellulose is deteriorating. But the oil, standard oil test, actually if you change the oil, it can improve the situation, because if the oil is bad, oil is a cooling medium. If oil acid number is bad, you put a new oil, the acid number will be good. Interfacial tension is bad, low, you change new oil, it will be good. Moisture will be good. You can filter the oil and change the oil. That is a very good action if many of your data is showing the bad result. Okay, so that is one of the thing one should do. Like I will check moisture content. If the moisture content is very high and my acid number is very high, more than 0.4 mg per g, and the IFT is less than 25, I will filter the oil, or even if the breakdown voltage is high, I don't do it, because breakdown voltage, as I said, it doesn't give a clear indication. Okay, so remember this: moisture content, oxygen content, and the acid number, interfacial tension. Breakdown voltage is not a very good indicator unless it is very late. That is the standard oil analysis. Now let's discuss the dissolved gas analysis, because dissolved gas analysis gives a lot of other data about the transformer health. So all of you know that there's a Duval triangle and all this kind of thing, but okay, you can draw Duval triangle. A lot of software available nowadays, but we can do some basic check actually. Okay, so what are the gas, the dissolved gas analysis check? It checks methane, ethane, ethylene, acetylene, hydrogen, CO, CO2, and total gas. So all of these gives a lot of data. Okay, so if the methane and ethane, CH4, C2H2, yes, if methane is more than 400 ppm and ethane is more than 100 ppm, it shows that low temperature overheating. Okay, that means what? That means there is a sustained thermal stress. It is not a one-off or at a hot spot or something like this. If your methane and ethane is high, it is sustained thermal stress. That means your cooling is not good, your temperature is high, or maybe oil quality is low. So that is one analysis. Okay, maybe the core is getting heated up, maybe the core is shorted, maybe the core grounding is not good. So that is to be checked in the next turnaround. If the methane and ethane goes, methane more than 400 ppm, ethane more than 100 ppm, it's a low temperature overheating. Ethylene is C2H4. Yeah, ethylene actually oil overheating. Okay, ethylene also comes from the hot spot, the core circulating current maybe, or the hotspot in the winding connections. So ethane, I will say like more than 100 ppm also. ethylene, more than 100 ppm is also bad. So the analysis is that there is a oil overheating happening from probably hotspot or core circulating. Okay. Next one is hydrogen. Hydrogen is the first thing comes out when you do a real analysis, because in a dissolved gas analysis, hydrogen is the first indicator that something is not good. It is an early warning system because it happens from the heat and partial discharge, localized heat and partial discharge. Okay, so hydrogen above 500 ppm is a very good early warning that transformer is deteriorating. This is the first sign of trouble. Okay, next one is the acetylene. Acetylene is a very high energy arcing is taking place. So acetylene is, if there is a high acetylene, high in the sense acetylene should be less than 5 ppm actually. So IEEE say, I think type 2 is maybe, let me check. Anyway, never mind. So acetylene more than 35 ppm, 40 ppm is really bad. There is a very high energy arcing taking place inside transformer. So acetylene is one should keep an eye on the acetylene. Hydrogen and acetylene. Hydrogen more than 500 ppm, acetylene more than 35 ppm, your transformer is going to fail soon. Okay. Next one is carbon monoxide and carbon dioxide. Carbon monoxide and carbon dioxide is very interesting. Carbon monoxide and carbon dioxide comes from cellulose. It is the solid insulation deterioration or overheating produce carbon monoxide and carbon dioxide. So this gives a very good indication of paper quality, paper insulation quality or solid insulation quality. So even if somebody don't do a full-on test, by looking at carbon monoxide and carbon dioxide, one can easily assess how my paper insulation is behaving actually. Okay, so carbon monoxide normally should be less than 500 ppm. Anything more than 500 ppm is very bad. And carbon dioxide should be less than 4000 ppm. Anything more than 4000 ppm is very bad. So all the data I am telling, it is basically IEEE condition 2 or condition 3, mostly condition 3, but some of them are, I mix up condition 2 and condition 3 based on my experience. So dissolved gas analysis summarize: methane, the more than 400 ppm is bad. Ethane more than 100 ppm is bad. Ethylene more than 100 ppm is bad. Hydrogen more than 500 ppm is bad. Acetylene more than 35 ppm is bad. Carbon monoxide more than 500 ppm is bad. Carbon dioxide more than 4000 ppm is bad. And when you talk about total dissolved gas, you exclude nitrogen and oxygen. Anything more than 1000 is not very good. More than 2000 is very, very bad. Okay, so this is the general acceptable, not acceptable scenario. Now what you do? Before I go to the what you do, I discuss briefly the carbon monoxide carbon dioxide ratio. As I say, the carbon dioxide, high carbon monoxide by carbon dioxide ratio, if it is high, it is showing that solid insulation is deteriorating or overheating. Or alternatively, you can say it should be low ratio of carbon dioxide by carbon monoxide. So high carbon monoxide by carbon dioxide higher than 5-6 is very bad. Conversely, carbon dioxide divided by carbon monoxide ppm less than 3 or less than 5 is very bad. It shows your cellulose is deteriorating. This is very clear. Okay, so now what do we do with this actually? Now we know that these are the data, and then when you see all these dissolved gas analysis is showing very bad, you should do a Furan test. The Furan test is like a degree of polymerization. We discussed that. For a brand new transformer, degree of polymerization base is considered 1000, and then when it goes below 300, the degree of polymerization is very high. Less than 250, the insulation is basically gone. and less than 250 transformer can fail anytime. If it is less than 200, it is going to fail very soon actually. Now the risk analysis. How do we risk analysis when to change the transformer or inspect the transformer? So as I say, we need to look into totality. So if we see a transformer having high moisture, high acid number, low IFT, interfacial tension, high dielectric absorption ratio, high oxygen, that means what is happening? That means there is a corrosion is taking place inside the transformer, and that's why the dissolved gas analysis will show various type of gas because of corrosion and other thing. So, but if the oil quality is bad, I think the great suggestion is to replace the oil or filter the oil. So for a critical transformer, replace the oil completely. It will be a very good investment, or filter the oil thoroughly, at least 3 cycle. 3 cycle means the total volume, the time should be at least it is three times of the total volume based on the filter oil capacity. But I will suggest if the transformer is 15-20 years old and the oil quality is very bad, it is better to replace, because you get a fresh oil, you basically stop corrosions if you want a 40-50 years transformer life. Dissolved gas analysis is tricky. As I say, we should concentrate on hydrogen and acetylene, which is high arcing. High arcing comes from where? High arcing can come only from the connections. The connections are winding connection to the bushing, or in the off-circuit tap changer or on-load tap changer. So that can be checked only by untanking. If it is connection side, it can be, you don't have to completely untank. One can lower the oil and check all the connection, winding connection to the bushing. Those could be by soldering many times, or brazing, and some of them are just connected into a bolt. That could go bad over years. So you can retighten that. You can check those connection. If you find something bad there, you know that's why it is giving a high hydrogen and high acetylene. That is one thing can be done without completely untanking the transformer. So basically, if it is a high hydrogen, high acetylene, the first thing I will suggest to lower the oil, expose the connection part, and check all the connections is correct. Another thing can be done. That's why I say during testing one should do a very good measurement of winding, DC winding resistance. If DC winding resistance measurement can be done after any time, after you lower the oil or even without lowering the oil, and if you see from base reading there is a deviation, that means some of your connection strand may be broken. Okay, like connection is bad somewhere. So that's why winding temperature, the winding resistance is slightly different, or maybe it is in the off-circuit tap changer. That gives another indication of why hydrogen and acetylene is high. So if that is the case, you look at the connection carefully. If your winding temperature, winding resistance is deviating, then it will produce hydrogen and acetylene. The advantage is doing this test. If you see the winding temperature is deviating, then you know there is some connection in the off-circuit tap changer or some connection, and then you know why hydrogen and acetylene is high, because maybe there is some connection. But then you really don't. Transformer can still run. You delete the transformer a little bit. You don't have to replace the transformer. It is not a real hotspot or something like this, because you know that there is a winding resistant deviation. That means there may be some connections issue. Or if you want to be 100% sure if the deviation is too high, you have to untank and look at the off-circuit tap changer cleat. Maybe there is a connection issue there actually, and it will also picked up by TTR. Then it can be corrected. Then if you put back again, the highly likely if you find something the connection issue, then hydrogen and acetylene will go down. If it is a methane and ethane low temperature overheating, that is basically your sustained temperature stays. So that you can delete the transformer a little bit. If it is ethylene, the core circulating current etc. may be bad, so one can check the core connections. Okay, and if it is CO-CO2 ratio is bad, basically if the CO by CO2 is more than 5 or more than 7, your solid insulation is deteriorating, so transformer will fail. So when to change a transformer, I will suggest that the from direct main oil analysis, standard oil analysis, there is no reason to worry about. If the standard oil analysis is showing bad result, you replace the oil and watch for what is happening in next 2, 3, 4 years. So transformer can continue running. And you try to adjust the system, like if your transformer is not hermetically sealed, your silica gel breather has to be good. The silica gel should be good, it should be replaced. If it is hermetically sealed, see what else is happening. Maybe your rubber bag may be leaking, so those can be taken care of. But if the oil standard oil test data is showing bad, it is not an immediate issue. Maybe the oil itself is bad at the first place. That's why there's a moisture. If there's a moisture, then interfacial tension will come down. And if there's a high acid number because of the oil quality, first oil quality, then and if there's oxygen and heat is always there, so your corrosion will take place. So transformer life will come down. So those you can replace the oil or filter the oil, and that's it. But if the dissolved gas analysis result is bad, then we need to plan for the transformer replacement. What is the time for transformer replacement? One, as I say, like CO and CO2 ratio and DP both. If the DP is less than 300 and your CO-CO2 is more than 7 or 8, CO divided by CO2 ppm, then it is time to change the transformer, because transformer will probably fail in 2-3 years time. If it is CO divided by CO2 is more than 10, and if your DP value is less than 250, your transformer can fail in next 1 year. Okay, so that is the from experience. So this is the thing to remember. So if your CO divided by CO2 is more than 10, and if your DP is less than 250, your transformer is going to fail in next 1 to 2 years. So you can plan based on that. If your CO divided by CO2 is more than 7, and if your DP is less than 300, transformer will probably fail in next 3 to 5 years. So you can plan based on that. So this is very clear guideline from my experience when to replace the transformer. And other data gives you an idea, like if your total dissolved gas is more than 2000, you are having trouble. If your hydrogen and acetylene is high, then you are having local hotspot, local overheating. And if your ethylene is high, you have oil overheating. If your ethane is high, you have low temperature overheating. Those tells you health of the transformer, but not imminent failure. Imminent failure is mainly CO by CO2 ratio and the degree of polymerization. Of course, high hydrogen and high acetylene also imminent failure, but then it will show up in other two ratios also. If you have very high acetylene, like more than 50, 60, you are having serious overheating somewhere, so it will create a fault. It is not a degradation type of failure. So hydrogen and acetylene is showing your fault hotspot that could eventually lead to a fault, but it is not a degradation of insulation or degradation of transformer. We are talking about transformer life of 40, 50, 60 years. So if you are looking at degradation, you look only on CO by CO2 ratio and degree of polymerization. These two only. And of course, total gas, etc., also give some other data. So if your dissolved gas is high, lot of vendors say, okay, replace the oil. That is not a good idea in my opinion. If you replace the oil, you lose your old data. But suppose you replace the oil because of the other oil analysis, you should keep your old data. And when you see the other dissolved gas data, you need to compare the old dissolved gas data also and try to take a judgment call. But as I say, like insulation degradation is mainly from CO-CO2 ratio and degree of polymerization. These two will come back very quickly, and ratio is important. CO and CO2, doesn't matter how much ppm. CO versus CO2 more than 7 is bad, and degree of polymerization less than 250 is bad. CO versus CO2 more than 10 and degree of polymerization less than 250, transformer is going to fail in 1 to 2 years. CO divided by CO2 more than 7 and degree of polymerization less than 300, transformer is going to fail in the next 3 to 5 years. That is the way to replace the transformer. What else I want to say? There are some other this thing nowadays. There's a lot of things like a partial discharge, ultrasound. You can do those kind of thing also, and those require a lot of expert analysis, and ultimately, if the experts replace the transformer, is not much help. So I think you can take a decision yourself based on the dissolved gas analysis, based on the other oil analysis. A good maintenance engineer can take decision of their own, and if you do all these things nice, transformer easily lasts 30, 40, 50 years. I have seen transformer operating 60 years in my earlier company. We take care of transformer very well. We do all these tests. Of course, transformer may not be fully loaded, but if the transformer even is fully loaded, it can last 40 years easily if you do regular oil analysis and take care of the oil. Like a lot of people don't give much attention. They are waiting for dielectric strain, and your moisture and oxygen and heat actually corroding, and then your transformer will develop a fault. So all are interrelated. Not one data gives you a data point. So you need to look at all data, think it over, and do the risk analysis yourself, and you get a very long transformer life. That's all I have today. So if you have any question, you can ask. If I made any mistake in a data, you can highlight that. I will correct that in my comment. I'm not going to correct the video. If you have any specific question, you can ask the question in the video. I will try to answer within 3 to 4 weeks. Thank you very much. Until you see you next time. Bye bye.